Hello, I'm Pilar Garcia from OnePassword, and today I'll share with you, Hello, who is this? A journey to stronger verification practices. OnePassword is a password manager. It generates, stores, and autofills passwords and login information for you. Customer data is end-to-end encrypted by keys only known to the owner of the data and never accessible to us. Our customers, however, often need help in getting in touch with us. Sometimes they want to let us know about a feature that they would like to see, for example, or sometimes they have an issue with one of the client apps, and then sometimes they need help with their OnePassword account. While we cannot access what people store inside their OnePassword account, we do have the ability to see what we call service data. Service data includes the following: the name given to us upon account creation, the email address associated with the OnePassword account, information about how the account is used and from where the account was accessed, as well as major actions taken in it, how it's being paid for, and details about the devices that are being used to access OnePassword. None of this is information that we would like to reveal to someone who does not own the account or who has not proven that they have a right to it. The more extreme example of this is a GDPR right of access request. Besides the service data that we can see, there are also certain actions we can take on an account. Some of these actions are related to billing. So for example, giving credit for the account or processing a refund for a charge. And then some of them actually affect the account itself, like changing the domain associated with it or removing two-factor authentication when someone has been locked out. While I've yet to see someone get upset for getting free money as credit, these again are actions that we only want to initiate once we have gained confidence that they have been requested by the right person. Until now, we have mainly relied on showing control of the email address associated with the OnePassword account for verification. Until we have sent a message to the email address on file and received an answer from it, we only provide general information. For example, share support articles and do not perform any actions on the account. This has caused some issues when the email aliases are involved, for example, or when someone has lost access to their email address. So, for instance, when a company changes their name and therefore their email domain. In cases where we needed to gain further confidence, for example, before providing logs or before completing GDPR actions, we have opted for a more creative solution, which is asking the customer to change their name or profile picture in OnePassword to a code provided by us. But I think we'll all agree that this is pretty gimmicky. We needed a better solution. And of course, we couldn't rely on know the password for identification because we don't know what it is ourselves. We needed a solution that made it easier for our customer support staff so they don't have to navigate a complicated decision tree every time they reply to support requests. But at the same time, one that does not add extra work for our users. And if at all possible, a solution that relies on math. So cryptographic signatures. Well, we spent some time designing this solution, making sure we had a strong implementation that would not only make us more secure, but also would make things easy for everyone involved. We eventually landed on what we call verified support, which I am going to tell you about. So the bulk of the work to implement this has been done, but we're still dotting the I's and crossing the T's, so it's not live yet. Anyway, let me tell you how it works from 3 different points of view. And I'm going to start by the users. If someone is in dire need of help with 1Password and wants to get in touch with us, they will find little difference from the current process. They still need to pick the general category of the issue that they're having and have a space to write a message to us with some details. But now they will also be encouraged to sign into their 1Password account if they aren't signed in already. Don't worry, if the problem is related to not being able to access the account, they can still send us a message without verification. On the other side, if you're one of us 1Password people ready to help, you should have configured CSX. This is a little tool that we have developed internally to allow our system that manages tickets and our back office to talk to each other. You'll be able to see a very clear banner that says verified right above the message in our support ticket system. Once you can see that, you know that this message was sent by someone who was signed into the 1Password account, and that you can now take the actions that they need or share the information about the account that will help get to a solution with confidence. If the message wasn't signed at all because they weren't signed into the account, then there would be no banner. And if someone were to mess with the cryptographic signature, then the banner would be red and prompt the person viewing it to get in touch with the security team so we can investigate. Now, let me walk you through what is going on under the hood. So, Alice needs some help. She navigates to the contact form on the site where she is prompted to sign into her account, and she does so. She then writes in her message to us and submits it. Then the client creates a hash of the email and signs that hash with her signing key, which is an ES256 key. These signing keys have actually been hiding inside 1Password accounts for a long time, in case we ever needed them. So let me tell you, we are pretty happy to have found a good use for them. So, the unique identifiers for both the member and the account, or UUIDs, and the region of the account, so whether it is in .com, .ca, or .eu, and the timestamp are added to this signed blob as well. The signed blob is sent to the server, which verifies the signature and generates a unique code to use as a key. It stores the signed blob in Redis for 1 week, and then the server returns this code to the client, which adds it to the header of the email and attaches it all to the signed blob. So now the email is sent, and then the email appears in our customer support tool. And Bob comes along to help Alice. He opens the email. CSX, the tool I mentioned before, reads the header and attachment in the message. It makes a request to the server by sending the code, the UUIDs, and the regions to it. Then the server uses this information to fetch the blob from Redis and verifies the signature by comparing the hash that was stored in the server and the hash sitting in our ticket system. Finally, if everything matches, the server returns a verified status, and the customer support extension shows the verified banner. Now, our staff can know that they can share details if they need to, and that the person who will receive them is indeed the person who controls the account. Keep in mind that we go as far as not even confirming whether an account exists at all until we have gotten confirmation that we're talking to the right person. While we believe this is the right thing to do for our customers, it also causes some convoluted conversations. For example, where we give someone the instructions to cancel a subscription in all the different ways that an account can be paid for, as opposed to just sharing the part that we know they need. This, of course, has certain limitations. For example, the issue I brought up before about verifying access right when someone cannot access the system doesn't get addressed by the solution. This does decrease the risk for human error, and it also makes doing the right thing the easy thing to do. So, we have covered our solution for improving verification when it comes to email. Now, let me share with you a little story. One day, as I was going through Git to see what had popped up in the past couple days, I saw an issue. Review a tool for phone support. It was one of those, wait, what kind of moments. I immediately reached out to the person who had submitted the review and asked them what was going on. Yep, we were going to start offering phone support in a limited capacity. It was a sure thing. Now, I knew that this day was coming. I just didn't know that it was coming later that month. So, as you can imagine, I let someone else on the team take the review of the specific tool and started talking to several different people on the team to make sure that we would be able to verify the identity of those on the other side of the phone. Our usual identity verification through control of email address simply wasn't going to cut it this time. So, I had a conversation with one of our developers who was very happy to jump right into the problem-solving train with me. And we came up with the following implementation. So, Alice, and please don't mind that Alice looks just like me, she's my evil twin, okay? Is logged into her 1Password account. She has navigated to the section My Profile. It all looks normal and what we're all used to see. And she's ready to hear from Bob. Now, Bob, who happens to be a bit hairy, is ready to help Alice. He finds her account in our back office system and clicks the button Generate CS Token for User. That moment, a code with 6 digits appears for him. And at the same time, Alice sees the same code appear on her own screen. She then is able to read it out loud, and Bob makes sure that it matches what he has on his side of the screen. These tokens expire in 10 minutes, and now Bob and Alice can talk about her account without fear of revealing any secrets to someone that shouldn't have them. The technical details for this solution are pretty straightforward. So, when Bob clicks the Generate Token button, the server generates a random 6-digit code and stores it in Redis. When Alice then logs into her account, the web app calls the server endpoint in the backend. The backend then checks on Redis whether there's a token for the user, and if there is, it includes it in the response. If the response includes this token, then the front end displays it. Otherwise, it does nothing. The server only sends the token if the person who initiated the request matches who the token is associated with. In other words, owners or admins of 1Password accounts cannot see a token for a different user of the account, even if they can access the profile. This implementation lets us verify ownership of a 1Password account without relying on email address at all, and has been already pretty helpful. However, it also comes with limitations. First of all, similar to our solution for email verification, it requires the person we are communicating with to be able to access the 1Password account. It also is a manual process. Our customer support representatives working on phone support have to make sure that they are following the policy correctly every single time. From a technical point of view, it can be bypassed. If you provide a service, you will interact with other humans. And we need to make sure that we are communicating with the right person and improve our systems and practices so that the burden of doing the right thing relies as much as possible on the technology and not on the people. Doing so is not always simple. Email messages that are automatically cryptographically signed provide a stronger verification than email control. A shared, time-based, single-use token in phone conversations is a stronger verification than simply trusting that if they join the call at the right time, then they are the right person. Thank you.